This is my modified Ender 3.
This is my Ender 3.
My slightly modified Ender 3.
And this is my slightly modified Ender 3. Hi, I'm Tommy, and this is my slightly modified and very broken Ender 3. Let's recap how we got here. Every video on this machine so far has shown us chipping away at the remaining stock parts, and it sparked a lot of curiosity. Let me explain. There's a classic analogy titled Captain Cook's axe, where the axe in question has its head and its handle swapped, which begs the question, is it still the same axe? This translates over to the Ender 3 and is the main goal for this project. By either modifying or replacing each stock part until there's nothing original or untouched left, I want to try and answer the red hot question, is this still an Ender 3? Here's my plan. First, we're going to take apart the entire machine and sort out what parts are still stock and staying. Second, the X-axis is getting a full redo with 9mm belts and double shear. The Y-axis is getting the same, but with some extra reinforcement. The Z-axis is receiving all the upgrades for hopefully brilliant print quality via linear rails and Oldham couplers, and then after that we're fixing up the electronics if necessary. Then finally, I've made the ludicrous decision to add even more extrusions to this printer, which I must admit is 80% for the thumbnail, 20% for potential improvements. But yeah, let the teardown begin.
It's basically just the frame left now, and yeah, it doesn't feel like much. Let's get the steppers off and then disassemble this. There's something so strange about just being able to hold the entire frame like that. Definitely not normal. Okay, let's fully tear it down. Now let's tidy it up.
Sweet, so we've got all the parts here. Now we need to take these extrusions, head over to the guy with the sandblaster and get them looking... Oh, sorry, one sec. Hello? Sandblaster's unavailable. Indefinitely. Alrighty. Change of plans. Let's get to the rest of the build without sandblasting, and hopefully we can do that later. Let's get to it. Yeah, that looks pretty great actually. These extrusions are going to be pushed inwards a little bit, so this is actually perfect. So this is what we've been left with so far. I've tidied it all up a little bit, and the remaining parts are actually just over here. But yeah, let's bring all that over here. I'm thinking I have plenty of other machines, well, that one's broken, that can do PLA and PTG, ABS and that sort of thing. So maybe I should get rid of the heater and save a few grams. I'll look into that later on. We can test adhesion. That could be nice for a little bit of extra performance. We'll see. Now, we've added quite a lot of stuff to the table. It's a full build. But you may have noticed that there's only 2040s here, and that's because I've actually got some spare 2020s in storage. Here they are. I was gonna build a large camera slider. So I have 600mm long linear rails. So yeah, I'll just end up cutting those to length. That'll be good. Okay, so unfortunately I do have to clear the table once more, but this time we're only gonna be leaving the frame pieces. Let's get to it. All right, first batch of prototype parts done. Alright, let's remove the new extrusions first. And we won't need the current top beam just yet. Let's start with the base of the frame. Now the sides. I doubt it's square, but that's a good first step. We can always realign it later. That's what I plan, at least. Alright, this is exciting. We get to actually start installing the new extrusions now. I'm not sure how square I can make them while installing them since I'm not tapping them yet, but I think I will. So this should be pretty simple actually. We just do that really. Now before I do knock all of these over, I think I should add a couple of these. Sweet, that's looking good for a temporary hold. I mean, it's strong, but the only problem is since there's only one single piece, I can of course twist this, but I am gonna drill and tap this later. This is just to keep everything, this is just to get everything ready for a test. I'm pretty excited. So now we do it to the other side. Alrighty, not bad at all. Now to mirror that on the other side. Okay, I'm gonna go all out with this one. I'm gonna do a super fancy transition. Go. Well, this currently just looks wrong. I'm all for it. Okay, now we need to cut the top pieces. Let's see how that goes. Okay, so the plan is to have a 20/20 go from here all the way to here, and then from here to over here. And then middle will be the same. This will be the same. Yeah, this is the top beam that goes on these extrusions here, and they've actually made it pretty easy for us to adjust. You can see there's two holes, so we just cut right in the middle of them. I'll just do this as a rough example here. Sweet, we've done that side now, and we've also done the other side, so let's see if it fits. Just gonna temporarily secure this. I think we should pause for a few seconds and admire this. Don't know why I keep ending up with these hilarious looking frames, but anyway, this is where we cut it off here, and luckily this remaining part here is exactly enough to fill in this gap here, and the other one, that gap there. It's gonna be great. So now I'm gonna grab those, put them down, and we can do some more chopping. All right, let's do left first. Sweet, not bad. That's almost perfect, although the frame will bend a little bit if I screw this down. So this is good practice for learning about keeping things square and all that. This will come in handy later during the custom printer build. Let's do the other side now. Cool, that's looking great. Not perfect, but still usable. Awesome. And this is how those are looking. Pretty neat. Now we just need to do the front and back beams. It's pretty simple what I do actually. I just take the extrusion, grab the hacksaw and cut off the part I want, and then sand it till it's perfect. Alrighty, looks like we're gonna cut right about here. I've roughly marked them. I could have done a better job, but this is enough. Let's go get these cut. Well, that's that, but I'm very interested to see how it will handle once it's all bolted down. Since there are a few gaps and it's far from perfect. But it's looking really, really cool. I'm pretty pleased with that. Since I have everything handy, I think I might drill and tap the top extrusions now. I have labeled them left, right, back, and front, which should make it nice and easy. I've also printed out some jigs, which is really cool. I look forward to testing these out and getting more practice. Yeah, this should make it easy to drill and tap. And yeah, I'll get some nice footage of that. That was super easy actually, and it looks pretty clean. Awesome. And that's all the 20/20 extrusions done. Nice. That was actually really good practice. Yeah, I'm looking forward to applying this more in the future. All right, now it's time to actually start tapping these extrusions and getting them ready. I also want to not countersink, but add an extra hole that's wider so that the bolt heads can fit in the extrusion. I butchered that. Yeah, never mind. Let's see if it works. It's not the best result, but I'm getting better, and this is actually really fun. Yeah, so now we can actually put the bolt in there. Hey, that's actually not too bad. I'm quite proud of that.
Awesome, we got it on both sides too. Now it's time to actually tap these. We've got this nice little tapping block to help everything align. I'm just going to push that through until it reaches the metal. Wait, I grabbed the wrong tap. Let me just switch this out. Oh, yep, I can feel it tapping into the metal now. Well, assuming that was the baseline, I guess I'll see you guys in 40 minutes. Alright, this is the second to last one. Now we're starting the final one. And that's it. We're finally done. Don't ask me what day it is. I don't know anymore. I think it's Friday. Well, that took a lot longer than expected, but all of these are now tapped, which is awesome. So are these tapped and drilled again? Yeah, let's tidy up and then get to assembling. Over there I'm printing out some of the parts I forgot, mainly for the X and Z axis. But I've just grabbed a bunch of stuff from over there. I'm going to work non-linearly. I can't keep planning, otherwise it's going to push me back even further and then I keep procrastinating. So yeah, got to get to it immediately. I think installing the linear rails will be a good first step. Got to install some heat set inserts into this part here. I ran out of the right sized M5 bolts before we even started, so I'll just have to deal with using longer ones, but that's alright. This is just mainly a mock-up. As long as I can get this thing printing within the time frame, that'll be great. I just worry I've bitten off a bit more than I can chew, but we should be alright. I've been trying to design these parts more with, I don't know what the term is, not countersunk, but like designing it so that the bolt head sits flush, and it's a really satisfying little thing. I'm not very good at it. Most of these have had to be forced in, but yeah, it's these little things that I'm really enjoying. Same with up here where I've bored or drilled out the this tensioner design is terrible, and I've printed it the incorrect way as well. It's just going to get pulled apart, so that's not good. Bearing tolerances, not very good either. Yeah, going live shaft is going to be interesting. There's a lot of new things I've started doing in this project. Might be a bit too much. On the bright side, I'm going to get lots of experience, and that's going to be good. I can find out what I do wrong and how to improve it. As always, I'm super grateful for any feedback that I can get. To continue modifying these machines, this video does have support from PCBWay. They laser cut the perfect carbon fiber parts seen on the Y-axis, as well as metal 3D printed parts for an earlier phase of this exact machine, alongside CNC machining and electroplating custom heater blocks for the custom hot end project a while back. Not only that, but it's also their 11th anniversary celebration until the 18th of July, where there are prizes and discounts up for grabs, so there's no better time than now to check them out and see what they can do for you and your projects. There'll be a link to them in the description below. It's quite an interesting design, so the X-axis beam is going to be on the other side of this. We've got one screw point here, 3 over here. I hope it'll be enough. I'm not sure how parallel it'll be. Yeah, we just got to go for it. This is a really neat part, and probably the only decently designed one in the entire build. I have the heatset inserts on this side, and I'm going to screw from the other side so that they can't be pulled out. It's going to be neat. Okay, so you guys know how I usually make some crazy mistakes per video. I designed that part. Nobody else did. There aren't meant to be 8 heatset inserts. There's meant to be 4 in the center. The holes were for the screws, not for the heatset inserts. I can't believe that. Well, I salvaged the heatset inserts, but the part, yeah, not so much. And here's the back Y-axis assembly so far. We've just got the actual idlers, and then we've got some washers on top, and the shortest M5 bolts I could find. It's a pretty neat little setup. I believe I can just install it like this now. Which way is it? Like this? Looks like the bearing tolerance for double shear is a little bit loose. That's alright, we can fix this. And that's the whole reason I printed these in all these nice colours, for little prototypes. Have a bit of fun. As expected, designing something for specific length screws mean other ones won't work. But if we install a motor, it's looking really cool. Let's grab the pulleys from Mallow. These are quite nice, 9mm ones. They're pretty big compared to the regular 6mm ones. I mean, they're 50% larger. Okay, these must be like precision machined or something. They're really hard to slide on and off, even with these loose all the way. I wonder if that'll help with accuracy, actually. I think the word eccentric and concentric are relevant, but I'm not smart enough to use them to explain. Okay, good news, everyone. I think we can get double shear to work on this. It just needs to be maybe 0.5mm or 1mm forward. But yeah, no, there's no interference or anything from what I can tell. This is so exciting. Oh, also, one fatal flaw I've realized is this. It's quite wiggly, and that's not good. So I'm gonna add that to the to-do list alongside these other little things. If this is another 40-minute video, I'm gonna lose my mind. Oh, it could be worse. I have got to get this working well with 9mm belts if I want any chance of using 12mm on the custom printer. Well, this is a bit unfortunate. Move out of range. And even though I modified the part to be a bit shorter so that it would theoretically work, it didn't. I'll go print the other one now and make some more adjustments to this just so that we have at least one bolt working. Yeah, I think I can make that work. I've mocked up these prototype mounts. They're meant to hopefully help with rigidity a little bit, but they mount like this, where they've got 2 bolts going up, 2 bolts going down, and 3 bolts going to the side, one of these on each side. I'm hoping that will help with the part here. I know I could have done something similar like the LH Stinger, but I didn't want to. Yeah, this will be interesting. Right, the tolerances on this are definitely incorrect, but, well, that's why we have these prototypes. I'm hoping by using the Eddy we won't have to use these 2 end stops to get the dual Z sync, but if we do, yeah, at least we have them, and I need to figure out how to use that in Clipper. Should be a nice learning curve. Alright, the part is done, printed in white ABS glass fiber. Oh, that looks so nice. Should be pretty strong too. So if I try and bend it, yeah, we're getting really scientific here. This is me putting all my force onto it. It's barely warping. That's amazing. Since I'm not expecting to need any more revisions on this part, I'm just gonna get the heat set inserts installed and then install it on the printer. So this part looks fantastic and it's completely flush on the other side. Even with the heat set inserts, I've trimmed them down. This is gonna be really great. We are also printing out some of the other parts that I know won't need revisions, which is great. I'm looking forward to seeing how they turn out. Oh, this is gonna look so amazing when it's done. Oh right, I didn't know the term yesterday, but it's counterbore, not countersink. Well, counterbore is this, countersink is where we use countersunk screws. I didn't know that at first. Now this was pretty tricky to pull off. The dimensions are a little bit tight. I'm surprised this even worked. I'm interested to see how this will perform because I would like to do a similar approach on a custom printer with dual MGM15s, but I'm just wondering, there's definitely a bit more resistance here, so I'm interested to see how this will affect wear, because I don't run my printers a lot, but if I'm building something proper, I'd like it to be as durable as possible. So yeah, this will be interesting to test out. It's all good fun. Alrighty, the parts are done. Let's take a look at them. Whoa, they're so pretty. Yeah, sweet, these look great. They're also blending in with the table. I'm gonna install the Y end stop and swap out the Z end stop things with the new ones. Nice and nice. All right, before I keep idling around finding other little things to do, I think we should get the Z-axis linear rails installed immediately so we can make more progress. Because the more time I spend fiddling around, the less time we might have later on. And, yeah, I don't want to be at the stage where we have like 2 days left and then everything's just falling apart. Now we can add some grease. That's 1, that's 2. Super easy. Installation height doesn't matter too much, but I'm going to use my 1, 2, 3 blocks to get that just about. Yeah, that looks pretty similar to the CAD. All right, that's number 1 getting installed. That's number 1 installed fully. That's looking really cool now. Despite labeling to print 2 Z motor mount bracket thingies, I did not, so I'm printing them now. In the meantime, I think we should get the big Z and X axis parts installed. I'm pretty stoked to see how this will turn out. I think best case scenario, my CAD skills have gone from bad to passable, but that's about it. That's another fun assembly, nice and installed. I'm pretty sure I printed this side. I don't know where I've put it. I'm so confused. It won't be hiding anywhere. Where could it be? Note to self for the future, always make sure to account for dimensions of things like the V-slot nuts. These things barely fit. Luckily they do. Should be easy enough. It's very likely that the quality of anything on the X-axis now is going to be affected by how good these parts are printed and assembled. So I look forward to testing that and getting a better understanding of that. Well, it does work, so that's pretty cool. I'm super excited to see how that will perform. What next? Let's add the Z motors. It's now time to grab these. Well, and these two. Now we've got the couplers installed. We need to install the actual thingies. What are they called? Why is the microphone here? Get out of the way. Oh, these are fun. Oh, these are really fun. Lovely piece of metal, these are. So nice. And now the anti-backlash nuts. Yep, nothing too fancy. Still awkward to assemble as always. I might buy some more of these just to play around with. They're so satisfying. It seems we didn't have audio for a little bit, but this is the final assembly. We can just slide this back on. Should be super simple. We just slide it back in like that. Yeah. Okay, I fixed that up so it's a bit more, I don't know. But yeah, that's looking awesome. That's exactly like the CAD. Oh, brilliant. And now we simply just duplicate that and put it on the other side. Now, it might just be me, but I'm pretty sure that end stop at its lowest is not hitting anything. Same for over there. So somehow I didn't account for that. Editor's note, please fix that. It is very rare that I design a part that actually works first try. I'm pretty pleased about that. Oh, that's awesome. Oh, I'm super pleased. A shame it's on something so simple, but we've got to start somewhere, I guess. However, left side, I'm pretty sure I've over-constrained this lead screw by a lot. Yeah, I'm like 110% sure that's affecting it. I don't know if I should remove it or if I should let the old ham couplers do the work. I genuinely don't know. I will leave it for now, but we will see. The Lego ketchup mustard color scheme is pretty interesting. I'm looking forward to making this thing all grey. Yeah, hopefully I can get access to that sandblaster. No word just yet. Finally, time to add the X-axis rail. So this is now our motion system situation. Back and forth, up and down. Oh, I can't move that up and down. And left to right. We're getting there. Yeah, as expected, we have basically no room up the top here. Might have to remove this top part. This is not ideal for double shear. You really want to either decouple your motors or get longer shaft ones. Like this example here from Mitsu. Let's grab some more bearings. Just one. And this part here that I designed. This is a pretty bad example, but you can see here, if we install this cover back on, the bearing can sit in there and support the motor shaft. I'm not sure how well it will do that, but please, any feedback you guys have, please let me know so I can learn from this. It's so fun trying all these different things in one go, but yeah, I'm gonna make a ton of mistakes. I don't even know if this part is just gonna explode upon use, to be honest. Pretty excited to see what will break and what won't. I think we should put the main board in now before later. Should we? Yeah. No promises on how good the cable management will be in this build, but I definitely want it to be better than last time. It'll be easily better than last time, yeah. We should be able to slide in the assembly nice and easily. There we go. I'll leave that loose for now. Let's get the bed stuff installed. Let's grab the stuff. Of course, we got the star of the show, the gantry, made of carbon fiber for minimal weight, metal spacers for more rigidity, since we have an eddy probe for leveling, and the actual bed that is a carbon fiber, PEI, and silicone heater sandwich. Come on, focus. And it is absolutely brilliant, but I am going to remove the silicone heater. The heating would be super useful, but cable managing, I don't think that's very possible at the moment, and it would just complicate things quite a bit. I'm gonna turn off the camera for this in case I butcher this. Before I forget, also having metal spacers on here, I worry is not gonna be as effective as having metal spacers on the actual carbon fiber, because this is a little bit squishy and I don't know how that's gonna play out. But yeah, any excuse I can find really. I've got my lab grade scale here. We're gonna put the silicone heater, carbon fiber bed, and PI plate on there with the gantry. 830, that's quite a lot. Oh, I'm butchering this. I apologize to anyone I offended doing that. 700, so 130 grams. Hey, that's a notable difference. Not as much as I was expecting though. Yeah, just the bed and the magnetic thing and the PEI plate is 600 grams. Maybe if we remove the magnetic sheet, but yeah, I'm gonna keep it as is. Sweet, so I'm just gonna install the gantry just like that, yeah. Because we've got the heatset insert on the bottom of the part instead of the top, we can tighten this as much as we want and it shouldn't pull out the insert. Oh yeah, this is gonna be really solid. Awesome. I don't think I can make this more rigid. This is so solidly mounted to the blocks, super secure. Oh, I'm so excited to test this. Alrighty, let's open the spacers. That's looking great. Instead of using some regular leveling nuts, we're actually going to use M4 lock nuts. That was recommended to me by someone. I'll put them on screen now. Well, I found one single M4 lock nut so far. I hope I can find some more, but that's the only one I've found. All right, bad news guys. It's been about 2 hours and I've only found one of these. Not because I've been searching for 2 hours. I was taking a break. But yeah, I'm giving up with that. We unfortunately have to use regular ones. Was that even? Yeah. That's all right though. It's hard to really show or feel on camera, but yeah, we've got that all installed now. And this thing just feels so solid, especially with the dual blocks. That's going to be amazing. With the metal spacers, I'm super excited to see how this will perform. Had to snap off the front parts of this thing so it wouldn't interfere. I thought I designed it right, but they do bend a bit. Oh, I'm super excited. I don't even care if this thing can't print any faster either. If it can print better, that's a big deal as well. Even if it's the same speeds as last time, but last time it was pretty bad. I don't know why these parts are so huge. I think I got my scales completely wrong. Anyway, this part is actually meant to go on the x-axis. You can see it's huge. There's a thing that goes inside here, and I've already forgot what I'm talking about. So without assembling the actual proper version, we have the pin going in between both sides, and basically what's happening here is the two bearings on the sides are taking more of the load than this would otherwise. Because otherwise we could wear this out more. I'm probably butchering this explanation. All right, I apologize. This is live shear. This is full live shear. So the pulley is mounted to the flat spot of this shaft, completely solid. Like if I rotate the shaft, it rotates that. And so the bearings now, when this gets pulled, the two outside bearings will take the force rather than the bearing on here. Just prevents you from wearing these out. And yeah, if you have some nice ones, it's probably cheaper to replace some bearings rather than these. Will I cut the shaft down? That's a great question. Alrighty, to compensate for this being somewhat decent, this does not work at all. It's stuck, and I had to force it through. So yeah, this is an immediate redesign, which is good, or not. The machine's quite a fun color scheme so far though. I must admit, this mount isn't as thoroughly designed as I wanted it to be. Although it should work. Turns out we have to tap the extrusion first, but that's all right. So it's pretty obvious creators of something have a bit of bias towards it. But this, and this are really bad. Really bad, really bad designs. This too, I mean, this didn't even work. What is this? It's spinning. Oh, I'm gonna have to adjust those. As long as I can get them working, that's the most important thing, and then I can refine them. But yeah, this is cool. This is a fun little thing, but yeah, not good. Here's the x-axis assembly. It looks hilarious. It sort of works. It's not amazing. I would like to do a full redesign, but that comes if we have time. What now? I think rest of the y-axis? Yeah. Okay, I've roughly added the heat inserts to the parts. They don't have to be that good considering these are just the prototypes. But as long as we can get these to work, I'll be pretty pleased. So what part goes on first? I believe it's this guy that goes on. How does this go on? It's gonna go on like this. I'm very interested. Is it? Yes, it is gonna go on like that. Then we've got the top plate, which is gonna go on there. That's gonna be brilliant. And then we've got all these other bits and pieces. I know something's not gonna work here. I wanna find out what it is. The way I designed this part was so that this part was flush here and we can have screws coming out for the hot end. Although I don't think I can attach the hot end if I attach it to the block now, so let's go grab it. This is the crayon hot end from Secit. They make the cool kits like the Secit SK Tank and SK Go. This thing should be similar in power to the Triangle Labs STD6 hot end. I believe it's a 140 watt hot end. It's a really nice design, I really like it. I bought it maybe 6-8 months ago. It is a prototype, I think, or is it a beta unit? And yeah, I'm hyped to try it. The thing is, at this price point, I think I paid maybe 150 New Zealand dollars for it, is it's right up there with hot ends like the Triangle Labs STD6 and the CHC XL, which are, I really want to test the XL, but they're both really capable hot ends. It's an interesting price point, interesting area. It actually reminds me of the custom hot end I designed last year. There's a part 2 of hot end designing coming out this year, by the way. That's gonna be exciting. Yeah, it's got 2 heaters on both sides. I'm expecting this to be super powerful, which I'm really hyped for. Right, the most important talking point, it is super rigid. So I'm really looking forward to taking advantage of all of these mounting points and just seeing how solid it is. Now, I was a bit worried about this. It is far from an ideal fit, but this has, oh, that doesn't look as good as I hoped. And there we go, that's the assembly so far. Some of you will have spotted this already, but yeah, this isn't gonna work. Back to the drawing board. I haven't designed too many of these, but this is easily the best, well, maybe not the best, but the strongest one so far. It feels really solid, so I'm interested to see how well it will perform. So this design here, hot end goes like that, this piece goes on top like that, and then it slides under. The Z is at its minimum, which is why it's like this. But it's the perfect sandwich, so if I screw it in now, it should be very solid. That is looking so cool. We got the fan, we got the hot end, no nozzle just yet. We have the extruder, everything works. What next?
Actually, I believe it's now time to get the CPAP parts installed. This should be interesting. Let's give it a go.
It's a decently rigid assembly. Should be alright. I hope this part mounts strongly to the others. Good news, everything's assembled nicely. Only issue is the ducts are lower than the nozzle. That's probably because of the heatset inserts or some other installation things. But yeah, I just need to adjust that. But otherwise, this is looking really, really good. Okay, well, I fixed it by bending the plastic, so now now the nozzle is lower than the ducts. Oh, it wasn't screwed in all the way. Okay, I can confirm it is still lower, but it is not ideal. I will work on that. But for now, we can move on. What were we working on?
Alrighty, it's time to install the BigTreeTech Eddy Duo and the turbo kit. It's both small and large at the same time. I'm really excited to try one of these. It's my first eddy current sensor.
Oh, that reminds me, my duct collection. Well, we've got the Kraken one there, and then we've got all of these other ones. And now, we can add him. Sweet. And a massive thank you to BigTreeTech for providing the Eddy and the turbo kit alongside so many other parts for this series. They've seriously been amazing and I can't thank them enough. If you guys are looking for anything from BigTreeTech, there'll be some nice links in the description. I think for the final design I need to have some more cable management in that part there, since I don't want the cable to get damaged at all. Oh right, I think I'm supposed to actually flip Eddy the other way around for interference, I think. I will definitely test it later, but it looks like we're all good and we have the, depths all sorted or whatever the thing is called. Yeah, okay. Toolhead is getting a bit bulky. I hope the cable management sorts it out. I'm gonna look into some improvements. This is so much fun. No, this is a good experience.
I really like the Universal Turbo Kit. I've used it in the past on the Ender 5 Pro build, and I'm using it again here because I know it will work. We've got the turbine in here, I believe. And drivers in here. Oh, they're the same weight. Maybe I'm lying. Yeah, this is gonna be loud.
Best thing I've seen all day. Oh, that's loud.
That means this box here will contain the driver boards. Ultimately, the mount I made is incredibly simple. It just mounts onto these 3 brackets here and then onto the frame.
The only thing I don't like is that I have to use these self-tapping screws, but that could be worse. And I didn't use them last time, so it's actually not that bad.
It's extremely likely that it's certain that there are better ways to do pretty much everything I show in this video, but these are the ways that I'm trying. Is this not going in? Why is this not going in? And I've made the mistake of spending 2 weeks in CAD, so now if something doesn't work, it's pushing me back even further.
Alright, I've got that mounted, and as for cables, I'm just going to run them along the side, to be honest. Cable management is one thing I always forget to plan. I also forgot to plan for some of the electronics wiring. That's going to be interesting.
Alright, let's unbox some of the circuitry. Sweet, I think we need to start doing some cable management soon. I'm a huge fan of these. I believe these are Vargol connectors, and they are very fun. And this part here is for the 24 volt input, just like that. Super easy, I love it. Because of all the pre-crimped wires and connectors and everything, it is one of the easiest fan modifications out there. Only a little bit more complex than installing some regular fans and all that. And then finally, these 2
go onto the fan port on your motherboard. So any fan port works, which is great. Well, as long as you have control over it. Alrighty, it's time for a little update. I've installed this new part here. It's alright. I've done a little bit of cable management, just a little bit. It's still not amazing, but I'm hoping it will be better. So the 2 power supplies are gonna be mounted here. I was gonna use 1, but I realized it wouldn't be strong enough, so I'm gonna use 2, and a buck converter to lower the 48 volts down to 24. We got the USB cable, lots of zip ties, love zip ties. And yeah, I think I'm gonna route this like that. All right, these are the 2 power supplies we'll be rocking. Let's get this one unboxed. They're basically the same. I made sure to account for these brackets here, which is cool. Need to install the new one since these, didn't work. I also reprinted this part. It is now a whole lot stronger. I just finished up printing these mounts for the circuitry. Where is it? For this thing here and for this thing here. I'm gonna mount them right about here. I actually think that's a tidier job than the one on the Ender 5, to be honest.
It's a bit taller than I am. Can't really see what's up there. Is it bad? It's probably bad.
I believe this is the final part we need to convert to ABS. So let's do it. All right, final 2 pieces. Just put that there. Twist this on a little bit. There we go. Legendary. I've done some thinking and I'm pretty sure this isn't meant to be toothed. I need to go check the CAD and see if I've made another catastrophic mistake. All right, I think some big changes are going to be happening, so let's do a little rundown of everything so far. We've got the tool head here. I've just added the extruder cable. I think everything's installed. We've got the ducts, we've got the eddy probe, we've got the nozzle, the hot end, fan, the extruder, everything's wired. That's good. The end stop for it is functional, which is good. Double shear on the X motor, everything's nice there. Tensioners are all white as well, which looks great. I fixed up the Y tensioner, which is really exciting. I'm very interested to see if this will work at all. Super strong, all these parts are super strong, which is nice. Well, as strong as plastic gets. Plastic is plastic. Mainboard, no wires at all. Bed, nice and rigid, although I need to fix up the part under there. Just need to readjust it. This is looking good. Still wish I had those lock nuts though. End stops are installed. Should be able to use them. Genuinely don't know though. The X-axis beam and the whole Z-axis thing is definitely something that could be improved upon. I think maybe having a piece that goes across there that links to 2 side pieces could work really well. Aside from that, the parts are looking good. Done some very basic cable management for these parts here. There is definitely a cleaner way of doing this. Power supplies are going to mount right there. The new brackets have been installed. They're looking nice and good. We've got the cables I need to sort out. And yeah, I believe that is everything. There is one thing we need to install now. That is the power supply socket. This is luckily a very simple mod. Alrighty, this is update time. I've just finished up the mains wiring. We have an IEC socket over here that breaks out into here and then goes into here. I've got connectors, everything. So next up is going to be the 24 and 48 volts going into the motherboard. I think I need a step down converter and also the Ender 3 power supply cables. They're getting a snip so that I'm not using the tinned. Alrighty, so the reason I do wiring off camera is because A, it takes a lot of time. B, I don't always want to show it because if I get something wrong, I don't want that shown to everyone for obvious reasons. And C, sometimes things just go wrong like this. I completely forgot about the USB cable for the eddy probe, and since it's the only way we can use it, I have to do something like this. I'm gonna get everything working as quickly as possible, and then, yeah. I've been trying to do a lot of research on dual blocks versus single blocks versus MGN15 blocks versus the wide blocks and all of this stuff. I don't know, no idea. I fixed it up though. It's now like flush across there, which is good. It wasn't before. And I've added some larger washers. So hopefully that'll be good. But yeah, I took the bed off so that we can easily access the electronics. Oh, that is a sight for sore eyes. Alrighty. What's really annoying is if I had the Creality High up and running, or basically any other printer. Dude, the value printer broke right at the end of the video. The heater wires were just a bit too fragile. Heater wires? Thermistor wires. That was my fault. I would print and design a whole new thing, but every printer is either out of order or too small. What a dilemma. To be fair, I haven't fired up the Ender 5 in like 7 months. Maybe it could be saving grace. I can't fiddle around with it now. Now, I like to think I did somewhat of a good move here. I used the heated bed ports for the heater just because I was a bit worried that this would draw more than the 5 amps continuous, 6 amps instantaneous that the board can do for the hot ends. But for the heated bed, it can do double that. So no risk there, and we don't have a heated bed. All right, it's now time to install the CPAP tube. Let's get this part on here. I need to get some zip ties.
the next day.
Okay, it is a big day today. I'm gonna install the belts today, even though it's still the same video for you guys. Now, here's the interesting thing. The right side, super solid. No backlash, nothing, no up and down. But the other side, well, that has a bit of a sound and it does move up and down slightly, and I can't figure that out if that's quality control with the old ham couplers or some other reason. I don't know. If anyone has any ideas, please, I'd love to hear them. So we're nearing the end of the mechanical side of things. So let's get the belts installed first, and then we can get the bed back installed. 9mm belts, they feel so much larger than 6mm ones, and of course, yeah, they're 50% bigger. I just hope I have enough, otherwise it's 6mm belts for the X-axis. I wanted to do something similar to Mitsubishi Makes' build. I think he borrowed that from somewhere. But I was a bit worried about the short spaces I was using on the corners here. Also, hey, I got pretty lucky with these fitting perfectly in these slots. Now, I didn't want to use zip ties, but I kind of forgot to print the prints for this. If this is a real issue, I will switch to printed belt clips. Because, I mean, the amount of tension that we're going to have, I think zip ties are pretty stupid. Oh, it doesn't look terrible, but I still have my doubts. I have my doubts about almost everything on this build, to be honest. Okay, I'm going to have to... Where's the end of this? Route this down here. Alright, that's one idler. And now I need to route this. Oh, easy. Just need to get that to the other side. Bit hard to see, but you can see there are the screws that bolt the extrusion to the frame, and they're getting in the way. So I'm gonna have to lift this up slightly and bring them down a bit, and then slide the belt through. Wow, that was a lot more frustrating than I thought, but we got there in the end. And now it's literally just route this like that, and now we chop it here. Pretty important I get the length right, so I think right there where my finger is, I'll cut. There we go. I think the only way to describe it is I'm a bit shocked and caught off guard with how easy that was. The belt path is there. There's quite a bit of resistance, actually. I think that's because of the blocks and all this. Well, that was quick. I found what was causing the extra resistance. I wonder if you can spot it too. Okay, the belt is definitely a bit loose, but that is like 1.5, 2 times better than before. Yeah, that's quite loose, but noticeably better. Let's tension it. Now, I'm not going to do any fancy app using or frequency tuning. I'm just going to hand tension it, see how it feels. And if anything snaps. I'd say we're already at usable tension. I'm just gonna keep going. It's got a bit of resistance. The issue is, I don't know how much resistance is too much resistance. Like, this will definitely work, but I don't know if we're losing power. I don't know if I'm wearing out the bearings. But yeah, again, need to figure out, is 2 blocks better than 1 big block, 1 wide block, etc. That is, however, a full belt path redesign with 9mm belts with live shaft in some of the areas. And I'm so proud of that. Great experience. Now, I thought I was pretty smart for having these little tooth ridges in there for the belts, but now I'm thinking, I really wish I did a similar approach to this, where I could have it wrap around and zip tied. Shoot, I've made this so much harder for myself. Let's get to it. One other thing that should be possible is actually removing the magnetic sheet in between the PEI and the carbon fiber, and just using those, what are they called? And just using those clips to hold the PEI in place. Plenty of them though to make it secure, but that could be great for getting rid of even more moving mass. Okay, we are getting there. Definitely a bit tricky. I need to apply some force. There we go. That is not going anywhere. Now this should be pretty simple too. We just put this through here. There we go. Now we've got it out the end, we just pull. Yeah. Just a quick update, I've done a new version of this part. Everything is smooth out the back, and there's this cut here for the belts to wrap around. Everything's printed a lot cleaner since I printed it flat like this, but I do wonder, I think this is subtractive machining capable. Alrighty, it's getting a tad late, so I'm gonna finish up today's work. We've got the belts all installed. They are looking absolutely amazing. I do need the path could do with a tiny bit of adjusting. That isn't making contact, should be okay. This needs a whole redesign. This needs a whole redesign. It is working though. And I can't find the electronics cover, but yeah, let's just get the bed off and I'll see you guys tomorrow. All right, good morning. Wiring wizard Tommy here. We're about to prove how good I am at wiring with first try. Nothing blows up. I'm amazing. We have some light back there. We have some light over there, here, and of course, over here. And here too. Come on, come on, come on. Oh, welcome back. Anycubic recently reached out for a collaboration and kindly sent over many spools of filament. You'll be seeing more of them in the next videos.
I asked if it would be possible to get some purple high-speed filament. Where's the label? So that's exactly what we're going to be using. Oh, beautiful. That's a lovely color. Let's put that straight into the Creality Space Pi 4 dryer. I do have ABS drying on the left side at the moment, but that's no problem at all. We can just set the right side to be PLA, just like that.
I don't normally vlog, so this is quite serious, but I'm naive. You guys know I'm pretty naive, but I don't think I can do a speed test with this machine just because I'm pretty sure every part I've designed will fail. So I am gonna have to wrap this up quicker than expected. Which I'm really sorry about, but it's been 1.5 months already on this machine, and with a couple of other sponsored videos coming up, I just can't afford to push this back anymore. Yeah, I'm a bit upset, but I'm gonna keep pushing and see what I can get out of this machine while I can. I'm just gonna go for it and start a print.
Now what's cool is we have Z-tilt installed, where it'll measure this left and the right side, and it will try and correct for the skew. Yeah, do we see that little movement? It's pretty cool. And if I run bed mesh calibrate, that's amazing. And I can make that faster, I can make that more detailed. It's absolutely amazing. And that's using the Eddy probe. Now, while I should run input shaper on the new Toolhead and all that, I think I'll do that later after we're printing. Alrighty, let's start up a print. I say we should grab the Anycubic filament from over there. It is very nice and warm. First extrusion test. I think I know that issue. Yeah, easy. I had the wrong gear ratio added. The Artemis extruder is always such a joy to watch. I love it. We should see some filament come through any second now. I'm interested to see if we will get heat creep as well. Hey, first extrusion! Let's try something a little bit mean with 48 cubic millimeters a second. 2, 1. Yeah, it doesn't have the right grip on the filament. Take 2. Okay, I think it's blocked. That was quick. Oh, I was really worried about this, but the whole heatsink is very, very warm. So I was hoping that wouldn't be the case at all. I mean, I guess I could counteract that by turning up the power on the fan. Oh, I've got to redesign that, preferably that as well. Shoot, that was 2 weeks of CAD. Well, I'm not too sure what to say now. So the issue is that the hob on this fan, or whatever this part is called, is too large and it's not getting the airflow to the heatsink. The other issue is Voron over there, jammed. Creality high, missing a part. Oh, I guess he could work, but not with ABS. Also, the heater wires on there are snapped, so he's... Broken printer? There's not much happening there. Yeah, I'm a bit stuck. I think I have to just go for it, unjam the Voron, and do this as quickly as possible. I'm still going to run input shaper so that I have something to show for my efforts, but I'm pretty sure results will be pretty different when I redesign everything, whenever I get around to that. So this is a bit of a compromise. I didn't want the fan to be like that. I wanted it to be vertical so that it would still look cool. I always prioritize the thumbnail as well when doing these videos, although airflow would be a lot better if this wasn't going straight into a 90-degree bend, but hopefully that covers us for heat creep. Let's run input shaper. I've decided to mount the accelerometer to the side on the hot end because that is a lot more rigid than the Eddy probe, and I can't do the nozzle because I don't want to uninstall anything around it. Regardless, I still at least want some graphs to give you guys, even if they're not 100% accurate. I need to tighten this down more. Luckily, I didn't need to flash any firmware to get the accelerometer ready. So now we've got the host, which is the CB1, we got the Eddy, we got the accelerometer, and we got the mainboard. All sorted. It's looking all right too. I used to be super intimidated with calibrating input shaper. I'm glad to say that's changed now. Yep, everything's starting to shake and rattle now. Oh, recommended shaper MZV. What was the value for that? MZV, smoothing. Where are the acceleration values? Hey, these are some pretty good values, I think, for something that's about to fall apart. Now the y-axis. Oh, that's not the y. Take 2. Take 2? Oh, that doesn't sound too good. It's making a lot of sound, so I've probably done something terribly wrong, haven't I? Alright, let's see the results. Please be somewhat decent. Of course, the real question is, will this prevent us from getting heat creep? Hey, we're extruding. No, there's no way that's working first try. Could be a little bit lower. Let's do one restart. It was a bit tricky to see with that huge probe in the way, eh? Just a heads up, I have not recalibrated pressure advance, retraction, anything. This is just what was there before. Oh, that's a lot of...
That's a bit too much CPAP. I worry that's gonna overload everything. Heatcreep again, is it hot? Pretty warm. I don't know what to do. You know what? I have a terrible idea. Okay, well, these are actually 24 volt ones, which are less powerful than the 12 volt ones, but should be still more than enough for, oh, this is gonna look absolutely ridiculous. This is the Ender 3 experience. I love this. Well, not in a time crunch. It always comes back to these high RPM axial fans, doesn't it? I think I've had, what, 3 or 4 videos on these things? They just keep coming back. And as much as I love this and think this is crazy, this is like 20% of what Gunnar did in his video with the 180 cubic millimeter hot end. I'll put that on screen now. When I hit enter, this thing's gonna go crazy. That's perfect. That's not too loud, and it's gonna hopefully give us the airflow we need. Oh, brilliant. All right, that's 48 cubic millimeters at 0.4 millimeters. Hit enter. It does it so quick. Wow. The thing is, right, we have an extruder here with so much pushing power, and we have a hot end that can actually melt the plastic. This is now 60 cubic millimeters. Sure, it's not the most accurate test, but the fact that it's not blowing up. Look how quick that is. It's just going. Oh. Again, this is a 200 at 10K benchy. I think it's warping off the bed. Oh, I haven't switched build plates. To be honest, that amount of cooling with no heated bed, yeah, that makes sense. Big Tree Tech actually sent this as a gift. I didn't ask for it, so I'm pretty excited to try it out actually. It's a beautiful color. Yeah. I'm just gonna run a quick bed mesh calibrate since I'm running really low on time. If I can't get anything out of this machine today, I'm just gonna have to call it. I love how quick that probes. I need to give everything justice, man.
All right, first print with it. Please don't scrape the bed.
That actually looks like a beautiful first layer. That's amazing. This is the best thing I've seen all day. Oh, that's loud. I'm trying again, but this time with like 8 millimeters of brim or something. I have much high hopes for this one. If it's good enough, I'm gonna call it because it's already late. I think it's warping again. Oh, I'm just gonna get some glue stick. Just gonna add a little bit, just a nice thin layer. I have unfathomably high hopes for this one. I think it's experiencing heat creep again. I have time for one more benchy. Once everything cools down, I'm just gonna go for it. If we can get a benchy, splendid. If we can't, I will find some time to fully finish this project in the next few months sometime, since that's the only fair thing after all this effort now. It's a little bit loud. Something needs grease. At least it's moving. I was also recommended to swap the, what are they called? The thingies I just installed. What are they called? The anti-backlash nuts with POM nuts, just to decrease friction. So I guess I'll give that a go next time. I think my hopes have been crushed for this video. I'm pretty sure we're also like 2 minutes away from heat creep as well. How visible is that from here? It's bending. Oh, I made that strong and it's bending. Well, it's still plastic. Still going so far. On the bright side, the filament is being melted properly. It is being cooled properly. It's got to be the motion system parts I've designed that are already starting to fail, because everything is good otherwise. Yeah, I'm going to take a long break from the Ender 3 after this. I'm really looking forward to tinkering with the Voron. There's a layer shift. No. There's layer cracking. There's pretty much everything that's on the All 3DP troubleshooting article. Alright, so this took about, what, 45 minutes? That looks, yeah. Looks like I've got some work to do for next time. A bit annoyed that it's going to have to be next time, but I hope it's understandable. Of course, it would be a bit unfair to Anycubic to showcase just one bad print with their filament, so let's showcase an actually good one. Alrighty, this took about 25 minutes with no part cooling as well. Yeah, I really need to get those fans working. I'm telling you, when I get the Creality High up and running, we're going to be printing lots more prototypes. I wonder if I can get up and running for the next video. Oh no, the Voron. Oh, how do I print parts for the Voron with the Voron? I don't know. We will figure it out. They're just so contrasting and so nice. I have given myself 1 more hour to get this better, and I've managed to eliminate maybe 50% of the friction that was there before. There is still quite a bit of friction or resistance, but after loosening and tightening some screws, this is a lot smoother. Let's give it one more go. I hate to say it, but I was right about this printer being on a time limit, as annoying as that is. New video, can I print a benchy before my Ender 3 snaps in half or falls apart? Coming soon. This is it. This is the first layer going down of a good benchy. I can feel it. Oh, and I still haven't done pressure advance. Alright, this one took about 45 minutes. It's better. I think my main priority is redesigning all of my custom printed parts, but if anyone has any feedback on something they've seen in this video that shouldn't be done, which I'm guessing there'll be quite a few moments, please let me know, and I'll do my best to improve. Let's get some close-ups, but maybe we don't want to do that. I genuinely think that looks worse than stock. Well, the chain is only as strong as its weakest link. We have a good hot end, cooling system, leveling probe, motors, everything. But the parts holding them together are costing us everything. Bit of a broken record here, but yeah. Looks like this finale is gonna need another finale. Alrighty, let's wrap this up.
I think the phrase 2 steps forward, 1 step back is very applicable here. I'm going to try and keep this outro condensed and hopefully shorter than some of my older videos. So where to begin? Well, technically we crossed the finish line as we did get a successful print with sufficient cooling and no signs of extrusion artifacts. I can also tune extrusion more, which leaves room for improvement, so that's great. However, I do think that spending half the project's time in CAD, resulting in only V1 and V2 parts mostly for this machine, definitely affected the later stages, since when I was halfway through the assembly, I was already getting worried about the time requirements for mishaps and of course editing and post-production. Now, normally this wouldn't be the case, but July and August are both meaty projects and videos, so pushing them back is only something I will do if absolutely necessary. All of this is a skill I am still learning and will do my best to keep getting better at. Every video is a step forward one way or another, and speaking of steps forward, I learned a ton in this video, and this is before reading the comments, which I always look forward to. First, I spent more time in Fusion 360 than I had ever done in one go, which was great for a variety of reasons. I'm hoping to make a dedicated video on 3D modeling in the future so that I can justify spending even more time there. I drilled, tapped, and counterbored extrusions for the first time, which was a great experience, and one that will certainly come in handy later on. While my double shear and live shaft executions weren't perfect, they were first steps into learning more about them and giving them a go. I will 100% be using them more in the future. Trying dual blocks was cool, and I'm certain that the issue is with the parts holding the idlers, as I think they're not perfectly in line, which is definitely causing the issues I've been having, since there shouldn't be that much resistance when moving the bed. The Z-axis will be getting some little changes too, notably removing the backlash nuts for just regular POM ones, and for the custom cross gantry later on in the year, I'm still unsure about going single MGN15 blocks or dual MGN15 blocks, or something entirely different. I gave the 80 sensor a go, and it was surprisingly easy to use, so I'm hyped to give that some more time in the future, especially with leveling for larger prints. I also plan on going with Beacon in the future, but not on an Ender 3. Going back to the motion system, it was a great learning experience trying to redesign every axis, although I greatly underestimated how long it would take, given my lower skill level. Since we did make a lot of progress this time, I'm hoping next time will be easier, but I honestly have no idea. I will keep trying to work on that video in the background, especially the CAD for versions 2, 3, and 4, etc. of the parts. I'd very much still like to get the frame sandblasted for aesthetics, so we should hopefully be able to do that in the coming months. I have used the sandblaster before, but its owner is quite busy. For those stopping by for the first time, I have another Limit style video up next on my featuring Stepper Online, who provided the NEMA 23s, Anycubic, who sent over some high-speed filament, PCBWay, who made some beautiful custom metal panels, and indirectly, Big Tree Tech, since I'm stealing the Kraken mainboard from the Ender 5, to go in the V0. I've done some planning, but assuming the amount of CAD and hands-on work I will need to do in this video, it could very likely be pushed back to August, alongside the 30 days with a large format video, which I will be producing alongside this one. That video features Eligo for the machine and Anycubic for the filament. It will be fun. Ultimately, we've made some killer progress on eliminating every stock and unmodified part on this machine, although we're not done. I will make sure that the supercard or movie will contain the final part, and we can finally call this project a close after 4 surprisingly short years. I could continue talking for a bit longer, but once again, I do have to wrap things up. So if you're right here at the front lines with me, sincerely, thank you for being here. It does really mean a lot to me. So, as always, thank you for watching, and hopefully, I'll see you again soon.